Hello and welcome to Excellent Link Academy. For today, we'll be considering a study of fluid mechanics as a course. So we're talking about a course called fluid mechanics. Let's discuss about this study of this course here. First, let's define the concept behind fluid mechanics. Before I define fluid mechanics, let's consider something first. Let's consider definition of fluid. All right, definition. A fluid is a substance that continually flow under and apply shear stress regardless of the magnitude of the shear stress. That's like definition for fluid, right? Let's consider mechanics. Let's consider mechanics. Let's consider mechanics. Mechanics is simply the study of the characteristics and properties of an object or a body, either at rest or in motion. That's the definition for mechanics. So it means that for our study of fluid mechanics, I have defined fluid for you and I've defined mechanics for you. Now let's combine them together. What's fluid mechanics? What's fluid mechanics? By definition, fluid mechanics is simply the study of the characteristics and properties of fluid, either at rest or in motion. That's the definition for fluid mechanics. All right, let's discuss something important called let's consider branches of fluid mechanics. There are about 3 branches of fluid mechanics, and they include number one, fluid statics. Number 2, fluid kinematics, and number 3, we have fluid dynamics. So these are like 3 branches of fluid mechanics that we have. We have the fluid static, fluid kinematic, and fluid dynamics. These are like 3 branches of fluid mechanics. Let's consider these 3 branches one after the other. Let's define fluid static. Definition: fluid static. Let's consider the first one there. Fluid statics. Definition: fluid statics is a branch of fluid mechanics that studies the characteristics and properties of fluid at rest. That's all. So fluid static is simply a branch of fluid mechanics that studies the characteristics and properties of fluid at rest. That's all. That's the definition for fluid static. Let's consider the second one there, number 2 there, called fluid kinematics. Definition: fluid kinematics is simply a branch of fluid mechanics that studies the properties of fluid, that studies the characteristics and properties of fluid in motion without due consideration of the force causing the motion. So I'm saying that fluid kinematics is simply a branch of fluid mechanics that studies the characteristics and properties of fluid in motion without due consideration of the force causing the motion. That's the definition for fluid kinematics. Let's consider the last one there, fluid dynamics. Definition: Fluid dynamics is a branch of fluid mechanics that studies the characteristics and properties of fluid in motion with due consideration of the force causing the motion. That's the definition for fluid dynamics. So having defined the three main branches of fluid mechanics, let's start with flow statics. Let's start with fluid static. When a fluid is static, that is at rest, what are the properties of such fluid, right? When a fluid is static at a position, right, what are some of the special properties that the fluid possess? So let's consider the properties of fluid. Let's consider the properties of fluid. Number one, properties of fluid. Number one, we have the adhesion. Number two, cohesion. Number three, surface tension. Number four, capillarity. Number five, capillarity. Number five, density. Number 6, 7, 8. We have 6. Number one, adhesion, cohesion, surface tension, capillarity, density, specific gravity, relative density. We have the relative density, viscosity. These are like the 8 properties of fluid. As you can see, let's discuss these properties of fluid one after the other. Let's consider adhesion, then cohesion, surface tension, capillarity, density, specific gravity, relative density, and viscosity. Number one there. Let's start with number one, adhesion. Definition. This is a phenomenon where substances which are different sticks together. So when substances which are different combine together as one, is said to be what the adhesion. So adhesion is simply a phenomenon where substances which are different sticks together. Let's consider the second definition there, called cohesion. Definition: cohesion is simply a phenomenon where substances which are the same sticks together. Now note this. Note that adhesion is when substances which are different stick together. Cohesion are what? Substances which are the same. So this is different, this is the same. Please, people actually make a confusion when defining these two stuff. When it comes to adhesion, the concept is that what? Different substances combine together. Cohesion, the same substances combines together. That's the concept behind adhesion and cohesion. Let's define the third properties, called surface tension. Definition: surface tension is simply the force that acts on the surface of a liquid or fluid, making it behave like an elastic stretched skin. That definition behind surface tension, right? The force that acts on the surface of a liquid or fluid, making it to behave like an elastic stretched skin, is to be what? Surface tension. Before we dive into the fourth concept, let me explain the concept behind surface tension. Let's say I have a tap. I have a tap, in this case, a tap this way, right? And I turn on my tap. I open the tap, water comes out, right, this way. Observe when I close the tap, the water will stop coming out, right? But observe that there will be a what? A droplet of water at the tip this way. When the water finish rushing out, there will be a what? A droplet of water at the tip. Have you experienced that before? Now, what's the concept? The water will not fall. Now, the concept is that the water becomes bigger and bigger, or perhaps weightier and weightier. Hence, it what? It falls. Becomes bigger, then bigger, then bigger. Hence, it falls. What was keeping the water from not falling initially? Why is it that the water becomes bigger and weightier before it falls? What's the concept? The concept is that the water was not falling initially because of what? The surface tension force. It means that the surface tension force is bigger than what? The weight of the water. Hence, the surface tension force keeps the water pending from not falling. But when the weight of the water is not bigger than the surface tension force, hence it falls. That's the concept. So the water becomes bigger than the surface tension force could no longer hold the water again, hence it drops. That's the concept behind surface tension. And also we observe there's some insects that work on water. What is keeping water? What's keeping the insects from not falling into the water? That's what the surface tension. That's the concept behind surface tension. Then let's go number 4 there. The fourth properties. Capillarity definition. Capillarity definition. Capillarity is simply the tendency of a fluid to rise and fall in a capillarity tube. That's the definition for capillarity, right? Let us call the fifth concept there called density. Density. That is called the fifth concept there called density. Let's call density. If I define density, note that there are 3 types of density. Type of density. Number 1, we have the mass density, also called specific mass. Specific mass. Number 2, we have the weight density. The weight density, also called specific weight. Finally, we have specific volume. Alright, so note that there are about 3 types of density. Number 1 is called the mass density, also called specific mass. Number 2 is called the weight density, also called specific weight. And lastly, we have specific volume. Let's define these types one after the other. Let's start with specific mass, or perhaps mass density. Let's start with number 1 there, mass density. Definition. Mass density is also called specific mass. It is simply the ratio of mass acting per unit volume of a fluid. It is represented by a Greek symbol called rho. It is called rho. A Greek symbol called rho. This rho, right? So mathematically, we are saying that mass density is also called specific mass. It is simply the ratio of mass acting per unit volume of a fluid. It is represented by a Greek symbol called rho. So mathematically, we are saying that mass density which is rho is equal to what? Mass all over volume. So mass density is simply what? Ratio of mass acting per unit volume of a fluid. So this is that rho is equal to what? Mass over volume. Of course, we know that mass is measured in what? In kilogram, volume in meter cube. Hence, the SI unit for mass density is what? The kilogram per meter cube, or kilogram meter to power minus 3. So this is like the SI unit for mass density. When it comes to the study of fluid mechanics as a course, SI units are broad, so SI units might be that confusing, please, and I'll take my precious time to explain those SI units very well for you. When it comes to kilogram per meter cube, I'm talking about the mass density, please. All right, this is like a mathematical expression for mass density. Let's go second one there, called weight density. Number 2, weight density. Definition: weight density, also called specific weight, it is simply the weight acting per unit volume of a fluid. It's represented by small w. So I'm saying that weight density mathematically weight density which is what? Small w is equal to what? Total weight acting per unit volume of a fluid. So specific weight is simply what? The total weight acting per unit volume of a fluid. So this means that small w is equal to what? Weight all over what? All over volume. Let's get SI unit. Of course, weight is measured in Newton, volume in what? Meter cube. So the SI unit for weight density is what? The Newton per meter cube. The SI unit, please take note of this SI unit, very very important, please. I'm taking my time to analyze this SI unit, please. So it means that weight density, the SI unit for weight density is simply what? The Newton per meter cube. That's like the SI unit for weight density. Let's discuss the third type of density. Before we move to specific volume, let's discuss the relationship between mass density and weight density. What is the relationship between mass density and weight density? Relationship between mass density, mass and weight density. Let's discuss relationship between mass and weight density, or if you want to, relationship between mass density and weight density. At this point here, recall that Recall that we said that when it comes to mass density, which is what rho, is what the mass over volume. We said this earlier, mass over volume. Also, recall that we said weight density that's small w is equal to what? Total weight over what? The over volume. At this point here, but from physics concept, from Newton's second law of motion, we know that weight is equal to what? The mass times gravity. Weight is simply the product of what? Mass times gravity. Anyway, I see W, I'll put mass and gravity there. So I'm saying that weight is equal to what? The mg from the second law of motion. So it means that weight density, that's small w, is equal to what? Total weight over what? The volume. But we said weight is what? Mass and gravity. That's what? Mass times gravity over what? Over volume. If I separate this one, this can be written as mass over volume times gravity. True or false? This is true. Mass over volume as this times gravity. So mass and gravity will give mass gravity over volume. This is mathematically correct. So, but we said, but from what we know that rho is what? Mass over volume. From what we know, rho is what? Mass over volume. And I'm saying mass over volume here. It means that specific weight W is what? The mass over volume represents rho. I'll have rho then times gravity. So therefore, the relationship between mass density and weight density is given as what? W is equal to what? Rho g. This relationship between mass density and weight density, that the weight density of a fluid is equal to the product of the mass density times gravity. This is very, very important formula you need to note in a study of fluid mechanics. All right, let's consider the third type of density that we have. Right, let's consider the third type of density called specific volume. Let's consider specific volume. That's alright, number 3. Specific volume definition. Specific volume is simply the ratio of volume to the mass of a fluid. Specific volume is simply the ratio of volume to its mass of a fluid. Is represented by small v. Note that specific volume is simply the inverse of mass density. Note that specific volume is simply the inverse of mass density. Mathematically, we're saying that V, small v, which is specific volume, is equal to what? Total volume all over what? The mass. We're saying that specific volume, that small v, is equal to what? Total volume all over what? The mass. But we know that volume is what? In meter cube. Mass is what? Kilogram. So the SI unit for specific volume is what? The meter cube per kilogram. As I can see, that's my SI unit for specific volume. But we said that specific volume is what? Specific volume, which is V, is what? The inverse of mass density. The inverse of what? Mass density. What we know is that rho is what? Mass over volume. Look at it. Look at volume. Look at specific volume and mass density. Specific volume is having mass down, volume up. Mass density is having mass up, volume down. So if I swap this one, if I swap the position, it's simply the inverse. So specific volume here is the inverse of what? Mass density, as you can see in front of you. So I've given you SI unit for each type of density that we have. Very, very important, please. Don't get them confused. Understand the concept. Alright, at this point here, note something, please. Very important. Note that the mass density of any substance are constant. Number one. Note that the mass density of any fluid is a constant. Number one, mass density of water it's important to know that the mass density of water is equal to what? Is simply what there? 1000 kilogram per meter cube or 1 gram per cm cube. Very, very important to know that the mass density of water is equal to what? H2 is water. So let's put this way. The mass density of water is what? 1000 kilogram per meter cube or 1 gram per cm cube. Very important. Note number two is that the mass density of mercury is simply what there? 13,600 kilogram per meter cube or 13.6 gram per cm cube. So if I'm given density of water, don't get yourself confused. It's simply 1,000 kilogram per meter cube. Density of mercury is what? 13,600 kilogram per meter cube or 13.6 gram per cm cube. That's like the concept behind what you need to note at this point here. Alright, there are about 3 more concepts to discuss. That's number 6. Number 6 properties of fluid is called specific gravity. Let's discuss specific gravity. Definition. Gravity is simply the ratio. Specific gravity is simply the ratio of specific weight of a fluid to its specific weight of water. Is represented by Sg. So mathematically, we are saying that specific gravity Sg is equal to what there? The ratio of specific gravity of fluid to its what there? Specific gravity of water. Alright, this is a mathematical expression for specific gravity, that the specific gravity of a fluid is simply specific gravity is simply the ratio of specific gravity of fluid to its specific gravity of water. Now let me explain something at this point here. Let me emphasize on something. Let me explain one concept. The concept is that we know that fluid by definition consists of 2 parameters. Fluid consists of what? Gas and liquid. Now in this case here, I'm having water here. I'm saying fluid represents 2 phases. That's liquid or what? Liquid or gas. Now for liquid, let's say my fluid here is liquid. I can compare liquid with water. Let's say my fluid is gas. I can never compare gas with water. So get this right. I'm not saying this is not correct. It is correct. But the correct form will be specific gravity is equal to what? Specific gravity of what? Of liquid to water all over specific gravity of water. So get this right. You compare liquid with water. Compare gas with what? Air. Please, air. So that's like the concept behind this stuff. Note that specific gravity has no SI unit. Why is it so? Specific gravity, we said gravity is meter cube per second. So if I'm having meter cube per second here, sorry, specific gravity is what? Meter per second square. So if I'm having meter per second square here and meter per second square here, they will cancel out. So there's no SI unit here. Or perhaps I'm having specific gravity, they are the same, they cancel out. So I'm having no SI unit for specific gravity. The ratio of the gravity of a fluid to its specific gravity of water. That's the definition for specific gravity. Let's call the seventh properties of fluid called relative density. Let's consider relative density. Let's consider relative density. Number 7. Let's consider relative density. Definition: relative density of a fluid is simply the ratio of density of a liquid to its density of water. Relative density is simply the ratio of density of a fluid to its density of a liquid to its density of water. So I'm saying that relative density is simply the ratio of density of a liquid to its density of water. So I'm saying that relative density, that's RD. You see what the density of a liquid to its what the density of water. Alright, so the mathematical expression for relative density is given as density of liquid over density of water. Don't cram this stuff. Understand them, please. Understand them. Alright. Note that at this point here. Alright. Okay. Note that relative density has no SI units. Why? Density kilogram per meter cube. Density kilogram per meter cube. They'll cancel out. So observe that relative density has no SI units. Please, very important. No SI units. Alright. Note one thing very important at this point. Note that specific gravity is equal to relative density. Specific gravity is equal to what? Relative density, mathematically. So I'm saying that specific gravity is the same as what? Relative density. That's for your level. When I did my own research, they are not actually the same thing, but we assume that what? They are the same thing for a level. When I did my research, specific gravity was about 14.9. When I did my relative density calculation, I had 15.2. So for my own idea here is that specific gravity and relative density are approximately the same thing, but what? Not exactly what? The same thing. But for this concept here, we assume that what they are the same. So assume that what they are the same. If that is true, so we're saying that if this is true, we're saying that specific gravity is equal to what the relative density, which is equal to what density of liquid over what the density of water. So now what we know is that density of liquid can also be called the mass density. So permit me to make density of liquid as rho. So it means that look up please, either of the two. If let's say I want to use specific gravity here now, it means that specific gravity Sg is equal to what density of liquid, which is what rho mass density over what density of water. That's what the 1000. So I have 1000. So it means that from here now, it means that the mass density of a liquid, or perhaps density of water, that's rho, is equal to what the specific gravity times 1000. A very important formula you need to note, that the density of liquid, which is known as mass density, is equal to what the product of what specific gravity and we multiply rho times 1 will give rho, this time this will give this one here. Or perhaps you can also change specific gravity as what relative density. Let's say in a question you are given density and you're also given specific gravity. Or perhaps let's say you are given, you're looking for density, given specific gravity. Record this formula. Density is equal to what specific gravity times 1000. Multiply the given specific gravity by 1000, you have a density. Let's say in that case you are given this density. We said this and this are the same thing. So if I say rho is equal to specific gravity times 1000, it means that rho again is equal to what relative density times 1000. They are still the same place. These are very, very important formula you need to take note of. Alright, remain one concept, that's viscosity. We'll be discussing about viscosity in our next class, much more better. But let's use all these concepts we have learned now to solve some past questions, and let's see what we can do. Welcome back. Let's use all these concepts we have learned to solve this example here. Example says, calculate the specific weight, specific mass, specific volume of an hydraulic fluid whose specific gravity is 0.85. Solution. First step in science is what? List out the given parameter. What are we given? Calculate what the specific weight. I'm going to calculate specific weight. So number 1 there. Specific weight, that's small w. Unknown. Second question says specific mass. So number 2 there. Mass, that's rho. Alright, specific volume, number 3. Volume, that's small v. And also, okay, that's all. Calculate the specific weight, specific mass, and specific volume of an hydraulic fluid whose specific gravity. Number 4 there. Specific gravity, that's Sg, is what the 0.85. Alright, let's get this done. Now at your level now, you don't say because specific gravity is the first one we're looking for, so we must look for this one first. No, at this level now, you pick the one of your choice, the one that will make it easy for you to find all this parameter. I'm only given one thing, which is what? Specific gravity. How do we find all of this? So now at this point here, since I'm given specific gravity, which formula, listen, oh, which formula relates specific gravity with all this here? Don't forget that we said, but record that we said that, look up, oh, we said that from this point here, look up from here, we said that mass density, that's rho, is what? Specific gravity times 1000. So it means that if I put this value here, I can easily add what? My mass density. So it means that my mass density now is known. So this means that mass density, which is rho, is equal to specific gravity times 1000. This means that rho is equal to specific gravity, we just said is what? 0.85. So I have 0.85 times 1000. This will give the mass density is what? 850 kilogram per meter cube. Observe my SI unit, kilogram per meter cube. That's for mass density. The SI unit, please ensure that you know the SI unit for each parameter. All right, I've got my mass density successfully. Next task now is to observe that I'm left with specific weight and I'm also left with what? Specific volume. Which one should I go out for first? If I say I want to look for specific weight, right, I can simply look for that. But observe that I can easily look for specific volume first before I look for specific weight. Why? Because okay, let's say let's say specific mass is for question I. Question II now. Let's dive into specific volume. Specific volume, that's small v. Recall that we said small v is equal to 1 over rho. That specific volume is equal to what? The inverse of mass density. We said this. We established this. So it means that small v, which is specific volume, is 1 over what's density? That's 850. If I punch my value, small v, that specific volume, is equal to, if I divide 1 by 850, I'll have 1.176 volume. We said the volume is what? We said specific volume is the ratio of volume to its mass. That's what the meter cube per kilogram. Please observe your SI unit, please. All right, sorry, times 10 to power minus 3. So meter cube per kilogram as my SI unit for specific volume. All right, let's get the last one done there. I'm done with this one here. Yeah? Let's get specific volume, specific weight done. So I specific weight what we know that specific weight small w is equal to what? The rho times gravity. We established this when we are dealing the relationship between specific mass and specific weight. This relationship here, recall from this. So it means that specific weight is equal to density is what? I have 850 times gravity is what? 9.81. Specific weight is equal to multiply 850 by 9.81. I have 338.5. Weight, we said specific weight is what? Ratio of total weight to each what? The volume of a fluid. So I'm having weight, that's in Newton volume meter cube. So this is the SI unit for my specific weight. So this has to find this concept here using the idea I've just discussed earlier. If you found this class helpful, do well to like, leave a comment, and share to your friends and classmates. Next class, we'll look into the 8 properties of fluid known as viscosity. So in our next class, we're talking about viscosity, Newton's law of viscosity, type of viscosity, dynamic viscosity, and kinematic viscosity. Right? That's mo and no. Right? So we're talking about those stuff in our next class.